All right, let's talk about machine learning. We hear the term all the time, but today we're going to pull back the curtain and see how machines actually learn. And you know what? It isn't magic. It's a method, or, well, more like three core methods that are literally powering the technology that's shaping our entire world. So let's just jump right in. We throw around the term machine learning constantly, right? But have you ever really stopped to think about it? How does a machine truly learn anything? I mean, really, let's imagine the machine is just a student. How in the world do we teach it? What would its classroom even look like? Well, it turns out there isn't just one single way to do it. The entire absolutely incredible field of machine learning is basically built on three and only three primary teaching methods. Yeah, just three core strategies that can take a machine from knowing literally nothing to making some seriously complex predictions. Okay, so first up is what we call supervised learning. And the name kind of gives it away, right? Supervised. Think of it like a teacher directly supervising a student. And to really get our heads around this, we're going to use a classic example you see a lot, teaching a machine how to identify different kinds of flowers. So where do we even begin? Well, we start by giving our student, the machine, some data. But not just any random stuff. We give it very specific measurements, the kind a botanist might take. Things like the length and width of a flower's sepal and the length and width of its petal. This right here, this is our input. Now, here's the absolute key to all of this. For every single set of measurements we feed it, we also give it the right answer. We're essentially telling it, hey, these specific measurements, that's a sedosa flower. And these ones over here, that's a versicolor. This is what we call the output. And this whole process brings us to a really important concept, labeled data. That's all it is. It's just a data set where every piece of input, like our flower measurements, is tagged with the correct output, or label. And this stuff is the absolute cornerstone of supervised learning. I mean, without these labels, the machine is just, well, it's just staring at a bunch of meaningless numbers. The easiest way to think about this is what I like to call the flashcard method. It's perfect. On one side of the flashcard, you've got the question, the flower measurements, and on the other side, you've got the answer, the flower's name. The machine just grinds through thousands, maybe millions of these flashcards until it gets so good that it can look at a brand new set of measurements and guess the name correctly. It's learning from a complete answer key. All right, let's move on to our second method. And you'll see how this builds on the last one. Actually, scratch that. It's totally different. This is unsupervised learning. And just like before, the name pretty much says it all. This time, there's no teacher, no supervision at all. And right here, you can see the fundamental difference. With supervised learning, we had all that nice, neat, labeled data. We had the answers. But what happens when you don't have an answer key? What do you do when labeled data just isn't an option? Well, this is exactly where unsupervised learning comes in to save the day. We give the machine the exact same flower measurements as before, but this time we don't give it any names. We just say, look, here's a giant pile of data. We're pretty sure there are three types of flowers in here. Your job is to go find them. So the machine has to figure out the patterns and group them into clusters all by itself. It has no idea what a setosa is, so it just makes up its own names, like flower type 1, flower type 2, and so on. So if the first one was the flashcard method, this one is the discovery method. The machine basically becomes an explorer. It's venturing into this totally new land of data, and it has to draw its own map from scratch. It's identifying all the different territories without any guide, no pre-made anything. It's finding all that hidden structure completely on its own. Okay, on to our third and final method. And this one is really in a category all its own. It's called reinforcement learning. And this isn't about studying some big data set. Nope, this is all about learning from experience. It's learning by doing. And as the source material points out, this really is a special type of learning. It's not unsupervised, because it does get feedback from the world around it. But it's not supervised either, because it doesn't get a neat little set of labeled answers to study from the get-go. It just exists in this fascinating middle ground of action and consequence. So how does it actually work? Well, it's all about a continuous feedback loop. Super simple, really. First, the system just tries something. It makes a guess, it interacts with its environment. Then, the environment gives it some feedback, maybe a reward for a good move or a penalty for a bad one. And finally, the system takes that feedback and adjusts its behavior, always trying to get more rewards and fewer penalties over time. This is so much like that hot and cold game we all played as kids, right? The machine takes a step, the environment says, ooh, you're getting warmer. That's a reward. Or maybe it says, nope, getting colder. That's a penalty. And just through that constant cycle of trial, error, and feedback, it eventually learns the best path to the goal. All right, so there you have it. We've met our three little students: the one who studies with flashcards, the one who's an explorer drawing a map, and the one who's just playing hot and cold. Now let's put them all side by side so this really sticks. And this really just brings it all together perfectly. You've got supervised learning, which uses that labeled data, that's our flashcard method, to predict a specific answer. Then you have unsupervised learning, which only has unlabeled data, and its job is to find hidden patterns, that's the discovery method. And finally, reinforcement learning, which starts with no data set at all and just learns through feedback, our hot and cold game. It's really that simple. 3 different students, 3 totally different ways of learning. And look, it's so important to remember that these are not just abstract ideas for a computer science class. These 3 methods, they're powering everything, from the app on your phone that sorts your photos all the way to systems that are making medical diagnoses. We've basically just peeked inside the classroom to see how they're taught. So that leaves us with one last and maybe the most important question of all. Now that we understand how they learn, what's next? What happens in a world that's going to be run by these incredibly powerful students?